Hello everyone, welcome back to Z Physics. Today we're going to be solving an admissions paper from Cambridge University. This is a paper that is taken if you're interested in applying for natural sciences, and it contains section 1 or section A, which is all about mathematics. Then you need to choose one more section. And in this case, I'm going to be solving the physics questions. I've left a link for that paper in the description of this video, and let's get started with the questions. So question 21, shortly after opening her parachute, a free-falling parachutist of mass 60 kilograms including equipment experiences the forces shown in the diagram. So we have the drag upwards with 900 newtons and the weight downwards with 600 newtons. Which line gives us the size and direction of the acceleration of the parachutist at this instant? Okay, well, this is a classic Newton's second law problem, so we're going to say that the net force, the sum of all forces, we can write that as such, is going to equal the weight minus the drag. So the sum of all forces by Newton's second law will be equal to the mass times the acceleration. The weight is just equal to mg. Well, we know that that's 600 minus the drag. So what we're left with is that ma will be equal to the weight, which is equal to 600. Let's take away the drag, which is 900. Additionally, we know that the mass is 60 kilograms. Yeah, it says 60 over here, like so. So we can directly just find the acceleration. 60 times a will be 600 minus 900, so that's minus 300, which means that the acceleration will be minus 300 over 60, which will be minus 5.0 meters per second squared. Now, because we've taken upwards to be the negative direction, this means that the acceleration is pointing upwards and has a magnitude of 5.0 meters per second squared. Therefore, the correct answer is C. Question 22, the displacement time graph shows shown represents a wave of wavelength 1.5 centimeters. So displacement time graph, what is the speed of this wave? Okay, so in order to determine the speed of the wave, we're going to use v is equal to f multiplied by lambda. The displacement time graph, will be able to figure out the time period. So this is just the distance from here to here. So that's just one time period. And we can say that the speed of the wave is, because frequency is 1 over the time period, this will be equal to lambda, the wavelength, divided by t, which is 1.5 centimeters divided by 2 seconds. So that's going to be 0.75 centimeters per second. Therefore, the correct answer is C. Okay, so question 23, we have a point mass traveling at a constant speed, has a momentum of 30 newtons per second and a kinetic energy of 150 joules. We're looking for the mass of the object. Okay, so let's write what we know. We know that the momentum is 30 newtons per second, so we know that P, the momentum, which is mass times the velocity, in other words mv, is equal to 30 newtons per second. We also know that the kinetic energy, let's call that E subscript k, that's equal to a half mv squared, and that is actually equal to 150. Actually, rather than the kinetic energy, I'm just going to write 150 here. Okay, well, since we know that mv is 30, what we can do is just simply write this as 150 is equal to a half times the mass times v again. So that's a half mv squared, really. But hang on a minute, have a look at that. We already know what m times v is, that's just 30. So we can just rewrite this as 150 is equal to a half times 30 times v. From here I can actually just figure out the velocity. So this here is 15, which means that V is equal to 150 over 15. So this just be equal to 10 meters per second. Because my momentum was 30, obviously P is equal to 30, so 30 is equal to mv. This means that the mass will be 30 over the speed, so it's going to be 30 over 15 and over 10, sorry, which means that our answer should be B, 3 kilograms. 24. Which of the following is a correct unit of potential difference or voltage? First off, amp per ohm, so that's current divided by resistance. This is incorrect. Remember, V is equal to I times R, so it's going to be amp ohm, not amp per ohm. Okay, B, coulomb per joule, that's incorrect. So remember, a different formula for voltage is that voltage is energy divided by charge. So it will be joule per coulomb rather than coulomb per joule. Joules per second, that's incorrect. That's just power. Newtons per coulomb, absolutely wrong. Watt per amp, well, this has to be correct. Additionally as well, if you remember, power is equal to V times I, which means that your voltage will be 1 watt per 1 amp, because power is because voltage, excuse me, is equal to the power divided by the current. Question 25, we have a radioactive isotope decays to a stable product, and we have a sample of this isotope is placed into a radiation detector in a laboratory. A graph of the count rate against time was plotted to display the data from the detector. Okay, so initially something is radioactive and is decaying, so we're getting quite a high count per minute, 450, that's pretty high, and then you can see that it's exponentially decreasing to a constant value. Now there's going to be a constant background radiation that will be hitting the detector that will not be due to that radioactive element, because that has already decayed. Because the count rate goes steadily to 50 counts per minute, this will be our approximate count rate due to the background radiation for this experiment. So the correct answer has to be D, 50 counts per minute. Okay, question 26. We have an object of mass 5 kg falls from rest and hits the ground at a speed of 20 meters per second. Air resistance is negligible. What height has the object fallen? Gravitational field strength is equal to 10 newtons per kilogram. Okay, first off, we have a little bit of surplus information. We don't need the mass. The rate of fall is completely independent of the mass, so we're not even going to look at this. Okay, well, the easiest way would be to just use the Suvart equation. So we're going to use V squared is equal to U squared plus 2AS. U is the initial speed, so that's 0 because it's falling down from rest. So V squared is going to be equal to 2AS, meaning that S will be equal to V squared divided by 2A. So that's going to be V is 20, the final speed, 20 squared divided by 2 times 10, which is going to be 20 squared over 20, which is just 20 meters. Therefore, the correct answer is B. Okay, question 27. So we have a cyclist and a bike have a combined mass of 100 kg. The cyclist freewheels, i.e. rolls without pedaling, that's pretty fun, at a constant speed of 0.8 meters per second down a slope, where the cyclist descends 1 meter for each 10 meters traveled along the road. Okay, calculate the loss in GP as the cyclist loses 100 meters in vertical height, and hence calculate the total resistive force on the cyclist and the bike. Okay, well, first off, the first bit is really easy. If the cyclist loses 100 meters in vertical height, they're going to lose a GPE of just mgh. So mgh is measured with respect to the floor, not with respect to the trajectory at all. So the amount of, let's call it the change in GPE, where GPE is gravitational potential energy, is just equal to mgh. So the mass of the cyclist is 100 times g, which we're assuming to be 10, multiplied by the height, which is 100. So that's going to be 50. So this is equal to 10 to the 5 joules. Now then we're going to use the fact that work done is equal to force times distance. It's actually equal to Fx cos theta. However, because the resistive force is acting along the line here and they're parallel, we could just use the equation that work done is equal to force times the distance. Okay, well, our work done by the total resistive force is actually responsible for the loss in gravitational potential energy. So our work done will be 10 to the 5 joules, and that will be the force multiplied by the distance. Okay, now if the cyclist loses 100 meters, they're going to keep their proportion to keep the slope constant. So if this here turns to 100, this one here is going to gain an extra to 0, so that's going to turn into 1,000 meters. So the distance will be 1,000, like so, which means that the force will be 10 to the 5 divided by 1,000, which is 10 to the 3, which is equal to 10 to the 2 newtons. So that's 100 newtons. Let's see which answer that corresponds. So that'll be answer E. Question 28, we have an electric motor is used to lift a load of 3 kg from rest from a height of 5 meters in a time of 1.5 seconds. And yet of the lift, the load is at rest again. The motor is connected to a 25 DC power supply, and we're assuming that it's 100% efficient. Okay, well, this question is all about the equation that power is equal to force times velocity. If we can find the power using that, then we can set it equal to voltage times current, and then we'll be able to find the current. Okay, well, if something is being pushed upwards or moved upwards at a constant velocity, if it's at constant velocity, the force will have to equal the weight, assuming that it's moving upwards at constant velocity. So our power will be then equal to the weight, which is mg, and then we're going to multiply by v. Now our mass is 3 kilograms multiplied by 10, and what will the velocity be? So it's going through a height of 5 meters in a time of 1 second, so our velocity will be just distance over time, assuming that it's constant, so it's going to be 5.0 divided by 1.5. So plug that into a calculator or just use mental maths, will give us 100 watts. Power is equal to V times I, therefore the current is equal to the power, which is 100 watts, divided by the voltage, which is 25, so it's going to give us 4 amps. The correct answer is D. Question 29. A ball is thrown vertically upwards and leaves the thrower's hand with a speed of 12 meters per second. You may assume that all of the initial kinetic energy of the ball has been converted to GPE when the ball reaches its highest point. What is the height above the thrower's hand to which it rises? We have the gravitational field strength is 10 newtons per kilogram. Okay, well, standard SUVAT problem. So V squared is equal to U squared plus 2AS, one of the most useful formulas. And in this case, at the top, there's no speed. We only have GPE, so 0 is equal to U squared, which is, 12 squared plus 2. Our gravitational acceleration is minus 9.81 multiplied by S. Oh, that's a little bit too accurate, actually. So let's assume that it's 10 for this question. So minus 10. And all we need to do is just rearrange for the height or the displacement S. So S will be 12 squared divided by 2 times minus 10 will give us minus, there's minus sign here, minus 20. So that's going to be 7.2 meters, i.e. correct answer is A. Okay, question 30. We have a lorry of mass M is traveling initially at a speed V along a horizontal road and then is brought to rest by an average horizontal braking force F in a time T. Ignoring any other resistive forces, what distance is traveled by the lorry during this time? Okay, the gravitational field strength is G for this question. There's There are probably a couple of ways of solving this question. By far the easiest way is to always use energy. So we know that energy is equal to the work done. The average resistive force will have changed its energy, and the change of energy of the lorry is actually a half times its mass times v squared, because it's initially moving at a speed v and then it's moving at a speed 0. Therefore, it's lost all of its energy, so the change of energy is equal to a half mv squared. Now, by the energy work done equivalence, our change of energy is equal to the work done. Our change of energy is equal to the work done, which is equal to the force multiplied by the distance. Let's call that d, multiplied by cosine of the angle, but in this case that is just going to be equal to 1 because they're parallel. Okay, so this means that our work done is equal to delta E, so that's just a half mv squared, like so, and this is equal to the force times the distance. Therefore, the distance is a half mv squared divided by f, which is mv squared over 2f, and this means that the correct answer is C. Question 31, we have a nuclei X is an unstable isotope which decays in the following two stages. So first off, we have element X with N and R. Remember, N is number of protons plus the number of neutrons, and the lower number R here will be the atomic number, which will just be the number of protons. Okay, now we can see that this is decreased by 2, which means that from here to here, from X to Y, it must have undergone alpha decay like so. So an alpha particle consists of 2 protons and 2 neutrons, which means that its nucleon number is going to be 4. So this actually means that we can say that P is actually going to be N minus 4, because in total, if it's undergone alpha decay when going from X to Y, it will have lost 2 protons. The 2 protons tell us that it's undergone alpha decay, which means that it's also lost 2 neutrons as well. Now, from there on, the number P remains the same. So in this transition, it means that it must have undergone some decay via the weak nuclear force, which is beta decay. So let's just say that this here is beta decay and this here is alpha decay. Because it's decaying to another element, I'm going to assume that it's lost another proton, or another proton has turned into a neutron. Therefore, the correct answer will have to be B. Now, if you're unsure why that is the case, I really recommend watching my videos on beta decay. Please see the link in the description. Okay, let's have a go at the next question, which is about ultrasound. So we have a pulse frequency 100 kilohertz is emitted from an ultrasound scanner and is reflected from a fetus 10 centimeters below the transmitter below on the mother's abdomen. The speed of sound within the mother's body is 500 meters per second. How long after its emission from the scanner does it take for the pulse to reach the receiver? Okay, just a little catch. So let's say that this here is the transmitter and this here is the receiver. So the wave will have to go and then it will have to come back. So the total distance traveled will be equal to twice the distance, which is 10 centimeters. So we're going to have to do that twice. So overall distance is going to be 20 centimeters. Okay, so time, because we're assuming the speed of sound is constant in this case, will just be equal to distance divided by the speed of sound. Our distance is 20 centimeters, so 20 times 10 to the power of minus 2, divide that by 500 meters per second, and that's going to give us 0.4 milliseconds. The correct answer is B. Okay, question 33, which is not too bad. So this is all to do with gradients, and if we calculate the gradients for all the graphs, then we can figure out that it's Q only. It's showing us a gradient for the acceleration at 2.4 meters per second. So the correct answer is Q only. Now notice that if the distance time graphs are a straight line, this means that they have a constant velocity. So here there's no acceleration, and here there is also no acceleration. Therefore the correct answer is Q, because the gradient of this graph is about 2.4. Okay, question 34. Consider this graph. Which of the following could the graph not represent if all the quantities are in SI units? So the variation of the acceleration of a body of mass 5 kg with the resultant force acting on the body on the x-axis. Well, let's figure out the gradient first of all. So let's say that the gradient is equal to delta y over delta x. So it's going to be 20 over 100, which is just a fifth. Okay, well, let's do a little bit of y equals mx plus c analysis. So for A, F is equal to m times A, which means that if we had acceleration on the y-axis, A will be equal to F divided by m, which means that our gradient will be equal to 1 over the mass times the force. And if 1 over the mass is 1 over 5, then it could absolutely represent this variation for a 5 kilogram mass. Okay, B, the variation of the current for a 5 ohm resistor with applied voltage. Okay, well, V is equal to IR. I'm going to have the current on the y-axis. I'm going to rearrange for I, which means that I will be equal to V over R, and that's a 5 ohm resistor, so our gradient will be equal to 1 over R times V, and 1 over R will be the gradient, which is going to be equal to 1 over 5. So this is absolutely spot on. It could work if the axes were labeled this way. Okay, well, let's have a look at C. The variation of the kinetic energy of a body of mass 0.4 kg with the square of its speed. Okay, so kinetic energy, let's call that EK, is equal to a half mv squared. So if you had the kinetic energy on the y-axis, y is equal to mx plus c, and if we had the square of its speed on the x-axis, then a half times the mass, so a half times the mass, which is 0.4, will be equal to the gradient, which is equal to a fifth. So that could also work, because a half times 0.4 is 0.2, which is equal to 1/5. Okay, well, let's have a look at D. So let's just rub this off, and let's have a look at D. The variation of the wavelength on the y-axis of waves with speed 0.2 meters per second and their frequency on the x-axis. So V is equal to F multiplied by lambda is the equation that we're dealing with, and we want the wavelength on the y-axis, so lambda will be equal to V over F, and we've plotted this with respect to the frequency. So this is not going to work because lambda is equal to V over F. If we plotted it with respect to frequency, we would get a very, very different shape. So D will not work. This does not go into y is equal to mx plus c format. In fact, the function, y is equal to 1 over x looks in a very different way. Question 35. The nucleus of the ion Q2+ contains X neutrons and X minus 3 protons. How many electrons does the Q2+ ion contain? Okay, well, if there are X minus 3 protons, if this was an atom, an electrically neutral atom, there will be X minus 3 electrons. Now, what this notation means is that this has lost 2 electrons. And if it's lost 2 electrons, it will actually contain X minus 3 minus 2, which is equal to X minus 5 electrons. Therefore, the correct answer should be C. Okay, next question. So we have 2 resistors, R1 and R2, which are connected in series with a battery that has a voltage V across its terminals. Which formula gives the power dissipated by the resistor with resistance R1? Okay, well, first off, let's see if we can figure out the current. Because the 2 resistors are connected in series, the total resistance is just going to be R1 plus R2. Well, V, our EMF in this case, will be equal to the total current, let's call that I, multiplied by R total, which means that V will be equal to I times R1 plus R2. Okay, well, we can say then that the current will be equal to V divided by R1 plus R2. Now, we can just use the fact that the power is equal to I squared multiplied by the resistance, which in this case is R1. So let's do that. So P will then be equal to V squared times R1 divided by R1 plus R2 squared, and this means that the correct answer is D. So, question 37. The graph represents the motion of a vehicle during a part of a journey. What is the best estimate of the distance traveled? Okay, well, we're going to need to be using quite a bit of area over here. However, notice that there is a catch. The time is given in minutes and the speed is given in meters per second. So the first thing I'm going to do is I'm just going to say that 1 minute is equivalent to 60 seconds. That's going to be 120. 180, then we're going to have plus 60 is 240, 300, 360, and 420 over here, just so that we have a little bit of an idea of what is actually happening. So let's split this into a few figures, and what I'm going to have is 15 times 60 plus the area of the triangle above, which is half base times height. So it's going to be a half times 60 times the height from here to here, which is 5. So this was this triangle here. Then we're going to look at this figure, which is so that's from 1 to 4, so that's 3 minutes, that's 180 seconds, times the speed, which is 20. Okay, and now let's estimate the next figure with a triangle. So our actual result will be smaller than this. So that's going to be a half times the base times the height. So the base is 3 minutes yet again, so that's going to be 180 multiplied by the height, which is 20. If we put that into a calculator, we are going to get 6,450 meters. Now, this is not actually the answer. The real answer will be smaller than that. I mean, we can see that the figure here that we've approximated with a triangle will actually be a little bit smaller. So out of all of those estimates, the only answer, which is a little bit smaller, is D. Okay, question 38. We have a sound wave which is produced by a loudspeaker cone which creates pulses of pressure by moving back and forth between the points X and Y. So essentially this is a speaker which is moving along this direction. Given the distance between the points X and Y is 5 mm and the loudspeaker produces pulses of high pressure every 0.2 milliseconds. The following statements about the sound waves produced are made. So P has a speed of 25 meters per second. This question is asking us which of these statements can be correctly deduced from the information given. So we have no idea what the speed is, and there's nothing that I can see that can tell us how fast it's actually going. All we can deduce really is the frequency. So has an amplitude of 5 mm? Absolutely not. So remember the amplitude is the intensity is proportional to the amplitude squared. So maybe if we had the intensity that we could say that, but we don't. R has a wavelength of 5.5 millimeters. Well, we don't really know anything about the speed of the pulses, so using the information given, we cannot really deduce that. Maybe if we were given the speed of sound, in this case, we could deduce that. Has a frequency of 5.0 kilohertz. We could absolutely deduce that because we're given the time period over here, and if we take 1 over 0.2 times 10 to the power of minus 3, we're going to get statement S. So the correct answer is S only. Okay, so question 39, we're almost there. The diagram shows a truck on a section of a roller coaster ride. The truck is launched from position P as shown and moves along a frictionless rail towards position Q. So essentially goes down there. The value of the Earth gravitational field and the initial speed of the truck are known. Which single piece of information, the key being single additional piece of information, is needed to be able to calculate the speed of the truck? Okay, so let's go over them one by one. Now, the mass of the truck in this case is virtually irrelevant because all objects are going to fall down at the same rate. I mean, even if you think about it in terms of energy, a half mv squared is going to equal mgh, so the masses are going to cancel out. So it's not going to be the mass. Now the distance x, well, this would have been so if there wasn't a little rise under here. So if we know x, we cannot really determine the speed at, well, at this point over here. So if we know x, we need to know y as well. So that's the that's the case. If we were to know y as well, we would need to know x, and exactly the same analogy can be worked out for answer Z. Straight line distance from P to Q will also be pretty much unusable. We cannot really use any sorts of equations for this. So by the process of elimination in an exam situation, we're going to choose answer E, the distance from P to Q along the rails. And that is actually the easiest way of tackling this problem, just using the process of elimination. And the final question about radioactivity, question 14. So we have the radioactive isotope carbon-14 is found in living materials in small quantities. Okay, and we're given the following ratio. So in everyday life, there are approximately 1,000 carbon-14 atoms for every 10 to the 15 carbon-12 atoms. Whilst the material is still living, the ratio remains constant. Yep, because even though carbon-14 is decaying, it's being constantly replenished. Yeah, it is actually being replenished in the atmosphere by cosmic rays, but that's a whole different story. When the material dies, the carbon-14 decays and is not yet replaced. The half-life of carbon-14 is about 6,000 years. Okay, so we have the new ratio is found to be 100 to 10 to the 15. So initially we had 1,000 and now we have 100 for every 10 to the power of 15 carbon-12 atoms. what is the closest estimate for the age of the bone? Okay, well, this is a classic question in which we're going to use our equation for radioactivity, that n is equal to n naught e to the decay constant minus a lambda over t. Now remember, the decay constant lambda can be found using the equation that lambda is equal to ln over 2 divided by the half-life, like so. So that's ln over 2 divided by 6,000. Because my answers are in years, I'm going to keep this half-life here in years as well. And this, when we put that into a calculator, it's about 1.155 times 10 to the power of minus 4. That'll be years to the power of minus 1. Okay, so we have our lambda. Now let's look at our equation again. So I'm going to say that n is equal to n naught e to the minus lambda t. Now if currently we have, for every 100 particles that we have now, there used to be 1,000 carbon-14 atoms in the past, multiplied by the exponential of minus lambda multiplied by the time. Okay, so we need to rearrange for the time. So let's do that. First off, let's do a little bit of cancellation. So 100 over 1,000, that's going to give us 0.1. And that's going to be e to the minus lambda t. So let's take the ln of both sides. So ln of 0.1 is equal to ln of e to the minus lambda t, which means that ln of 0.1 is equal to minus lambda t. Now that we have that, we can just rearrange for t, plug in some values for lambda, so it's going to be equal to ln of 0.1 divided by lambda minus lambda. Now lambda was 1.155 times 10 to the power of minus 4, so minus 1.155 times 10 to the power of minus 4. Put that into a calculator, and we're going to get 19935, which is about 20,000 years. Okay, folks, well, this was the physics section of the Cambridge entrance exam. Hopefully you're going to find this video useful. Remember, one of the main parts about acing this exam is time management. Thank you very much for watching, and I'll see you in the next video.